Hi, this is Paul, and welcome to Shading and Rendering. In this lesson, we're going to go over texture resolution and the process of determining a texture map size for any given 3D object in your scene. The scene that I have set up here is just kind of to emulate what you would get if you were to render out a 720 pixel by 540 pixel image. This would be a standard D1 size image that you would use if you were rendering out a project for broadcast television. So, as with anything in 3D, the first thing that you always need to do is you need to go back to your storyboards and see what you're actually rendering. So, if we were to jump in here and look at this crate that we're rendering for this project, and we'll just say with this crate, we're going to have one texture map on the front of this. We're going to have one on the sides, one on the top, and one on the back. So these will be split up into individual texture maps. So what we need to do is we need to determine what size of texture map we're going to end up putting on the front of this crate. Now, if we look at our storyboards, and inside of our storyboards, this is basically the size that is the largest we're going to end up seeing this crate. That is the size that we need to go off of. Now, this thing could get smaller. We could see it in our frame that size. It could be this size, whatever. Just as long as it doesn't get any larger than this, we can determine the texture size based off of this largest size. Now, you have a couple choices when it comes to determining the size of your texture map. And the way that this works is because of the binary nature of a computer system, it calculates stuff based on powers of 2 most efficiently. So to jump in and do a texture map, say 400 by 400 pixels, yeah, it will actually work, and you can use that as a texture map. However, your computer is going to be much more efficient if you base your texture map size based off of the power of 2, meaning 256 by 256, 512, 1024, 2048, and so on. So it's just good practice, and it's much more efficient if you work in these numbers that you see over here. Now, just for the sake of showing some industry terminology and stuff that you're going to hear when you're working in the industry, you will very typically hear, put a 1K map on that or put a 2K map on that. And basically what that means when somebody says 1K map, they're actually specifying a 1024 by 1024 image, 2K 2048 by 2048, and so on. Now, just a word of caution. Currently in Maya, and I'm working in Maya 2008, it will do a 4K map fairly easily. It starts to have some issues when you get up into an 8K map, and frankly, I've never even tried to put a 16K map on it, but I suppose that is a possibility. But for the most part, I try to keep it 4K and below. Occasionally I will stick an 8K in there, but again, you start to have some problems with displaying. Your video card might have some issues with it as well. So if at all possible, you're probably going to want to stick with 4K and below. Now, knowing this, and knowing that this is the largest we're going to see this crate inside of our little video frame that we're rendering out here, I can take a look at this and say, all right, well, here's the front of our crate, and I know that 540 pixels is this distance from this line to this line. So for me to go in and do a 1K texture on this front of this object is just overkill. It's not going to do any good. All it's going to do is basically slow down your render time. And, if you're only rendering this crate, might not be as big of a deal, but if you have a lot of objects in your scene, you really, really need to pay attention to speed of renders. I mean, if you've got a render that's taking a minute a frame to render, and you've got 1,000 frames to render off, you might get some fairly large render times, as opposed to, maybe if you use just a 512 by 512 map, you may get that render time down to 45 seconds or so. And over 1,000 frames, that's going to save a lot of time. So you need to constantly keep that in mind. Okay, so in this case, again, being 540 pixels tall, a 512 by 512 map would be plenty for this. Now, if, let's say, I'll move this down a little bit and over. Let's say that in our storyboards, that's as big as this thing is going to get, then once again, a 512 by 512 is going to be complete overkill for this object. And if you're seeing this thing quite large in here, you just got to kind of use your eye and say, well, you know what? This is this distance between here and here is approximately twice this distance. So we're seeing, maybe a 512 map would cover this, and then another 512 would cover that. So we would probably need a 1024 by 1024 or a 1K map in this instance to cover this entire distance of this and keep that resolution well in there. Basically, if we were to go in and, say, do a 512 texture in this case, and the camera actually moves in like this, we're going to be getting a lot of pixelation inside of that texture map. Kind of like in Photoshop when you pull up an image and we've got it at 100% and you zoom into 200%, you start to see some pixelation in that image inside of there. So that would definitely show up in your render there as well. So that's about it for resolution. You just kind of need to take it on an object by object basis and really keep an eye on what your storyboards are doing and how much this stuff is showing up in frame, just to keep everything optimized. There you go.